are the things going to happen. If you look at the university, what problem to solve, how to solve, and for this particular topic, how to solve it using the quantum machine learning. And basic of the quantum machine learning is nothing but the quantum computing. Then we can do the problem by quantum neural network, which is my basic domain. And this quantum neural network, if you wanted to know, is a hybrid, classical and quantum framework mixture. The algorithm behind it are the variation of quantum algorithm. And the problem which you are going to solve by using that is a combinatorial optimization. If I give the combinatorial optimization problem, AI cannot do anything. Because a lot of combinations we can mix together, so AI will not understand which way. Basically that if you look at, AI is always a unidirectional, not multi-directional. Okay? So if you just close your eyes and ask to hit the pot, nobody will understand. Nobody will hit. Sometimes the stick will come left or right. So that means AI is basically unidirectional, it is not multi-directional. That's why combinatorial optimization problem, AI hardly can do that. So you have to really hard in the computer programming, knowing the technology, and then algorithm evaluation. And then all these things we apply a new domain called Raman analytics. This is a new domain is coming. Generally, Raman spectroscopy we try to process for pharmaceutical or drug discovery. And that's why it is called the Raman analytics. And this is my own concept really. And when we solve the problem without having any AI, I found that a lot of pharmaceutical industries, they are very much attractive to understand their composition of the pharma. Okay. So now if you look at that, so the next point is that these are the problems we are trying to solve. The drug lead optimization for drug discovery. This is the resource optimization in wireless communication, logistics, and scheduling. They are the deep machine learning, and they are your astrophysical problem like astronomy, magnetic resonance imaging, and computer tomography. Okay. So now these are the various meaning of the lead optimization. Not going to details of that. But very interesting problems are there, drug discovery. You see a lot of things are there. Here, if you try to apply the AI, will give a bad solution. That also I have tested. Similarly, for biocatalyst discovery, the surface is 10 to the power 690. These are proteins, very difficult. Your machine will require really like a not GPU, not CPU, but you require a QPU, quantum processing unit. That's the new domain. So there are only 10 to the power 80 atoms in the observable universe, and you can see that how the system can respond that whole thing. Okay. This is of course we are having a quantum computing in our BARC and TIFR mixture with the IISc Bangalore. So there the experiment has been conducted, and we got the very few results. I will not say that the good result we have got. So this is the analytics of compressed sensing, that's sparse coding. We wanted to see that the black hole, the image is formed by that programming under the computer, quantum computing, and there are a lot many things like that. If you look at that, it is an optimization problem. So please remember that classical neural network or whatever you call artificial neural network is an optimizer. But if you try to get the good optimization problem, you require to have a quantum neural network. And this is the framework of analytics. We use the quantum machine learning. Okay, this is a new domain because whatever machine learning we do is a classical machine learning, but here it is a quantum machine learning. So it has got the variational quantum classifier. This is the working horse of the variational quantum classifier. I will encourage the students of the analytics to come to under this domain. Then we have a QNN, that is a part of the quantum machine learning, where you see that your quantum computer is here, process is taking place here, but when you try to get the result, that's a classical computer. It means there is the older generation and the new generation. It's called answer, and then you have a measurement. If you do the measurement, there is a decoherence. That means when you do the quantum computing, the qubits are the main workhorse. Okay, like the binary digit, that is a bit, which is the classical computer basic workflow. Quantum computing basic thing is that the qubit. And qubits are always in a superposition state. That means at the same time you can be either 0 or you can be at the 1. And that is why if they are entangled, by measuring one thing, you can get the measuring another. These things also Einstein could not understand. So he used the phrase that is spooky action at a distance. Okay, and the example of the spooky action at a distance is that very lot of movies are there where you can see that it is really that taking place. Okay, so these are the various workouts for the variational quantum. And as I mentioned that this is a quantum computing, they are in the superposition state. We have a superposition and they are in the entanglement, and all this process will be done by the quantum theory. Okay. So these are the superposition property. That means many of these things when you do, generally this thing is very difficult to understand. This is a tensor product. Because when you have an entangle, it is basically a tensor product of all the qubits. Okay. And they are the various gates. You see all the gates are nothing but a matrix operation. So basically one has to have the expertise on the operator theory. Okay. So what are the pipelines in the QAnon problem is there? You can have a feature vector, which are the classical data that have to export to the quantum data. Then feature vector is basically a simple just telescope numerical values. Then you have a classical, which is in the Euclidean space. Remember, the classical computing works in the Euclidean space, but quantum computing works in the Hilbert space. So I have to convert it to the map to the Hilbert space. So this mapping is very essential. AI cannot do that any kind of mapping. Okay. So now, when you do the quantum machine learning, for the training part, there are lot many regulation function in there. There is a loss function. These are all mathematical form of the various kind of loss function. And to do the regulation, we have the cost loss plus lambda. And lambda is the Lagrangian method of undetermined multiplier, or sometimes you got the penalty parameter. So then using that, even though we do the success of the quantum computing so far, but still it has got the weakness because I am showing here that the time of solution, as you increase the number of bits, qubits, the time of solution will be very, very large. You see, 150 qubits, the time of solution will be about 20 billion years. Okay. So that's the disadvantage. Of course, in near future, we may be succeeding towards that. So when you go for the quantum neural network, which is a part of your quantum machine learning, what we do, we try to connect the quantum process and then with the help of the optics. So optics knowledge is very, very important in this case. That means electromagnetism you have to know very well. So qubits are always in superposition state, I mentioned. So QNN will work within a hybrid quantum classical framework. Okay. We have mentioned that CHR mapping, when you do for the classical data to quantum data, you need the CHR mapping and some kind of quantum circuit called answer, and then you have a measurement and do the feedback. These are the various pictorial representation of how a quantum computation in the neural network then can be done. Okay, we will do some problem and then only. So our fourth pillar is data analytics. So in the data analytics, these are the four things you are required to know. That is a descriptive, what happens, diagnostic, why did it happen, predictive, what is likely to happen, and prescriptive, what should we do about it. If you take that the four start, you are expert of the data analytics. Of course, you require to solve every day at least minimum 10 problems. Okay. And your study hours should be almost 18 hours. So these are the predictive analytics and prescriptive analytics domains. I have shown here all the steps: data collection, data modeling, description, prediction, and prescription. Now when you go for the today what we are doing actually analytical environment, that is age analytics, we have a generative BI. After some time we will see that the SQL will be obsolete. Even today also we don't need any SQL. If you do the quantum computing, the database, we don't need the SQL. So structured query language, whatever you are learning, it is of no use. So then ethical governance, and then the goal is to turn the data into information and information into insight as part of the Cardiff arrangement. He is a philosopher basically. So now if you look at the data analytics pipeline for the QNN, is a classical quantum PHL map, quantum answer, then measurement, and then you are coming back to the classical code. So classical data to quantum data I already mentioned. You need some gate operation. You will come to know if you do the practice, not by this presentation only. So today's trend on the analytics of physics thing from quantum neural network. That is the only we wanted to mention here. And I gave this name physics from a net architecture. I have written some article. Very soon it will be coming to the Springer version. And then I mentioned here by 2026 the synergy of Lernon's molecular specificity and quantum processing power has turned every portable spectrometer into a laboratory gate diagnostic tool. So from that laboratory we are going to the field with the help of this kind of analytics. So your basic job in the analytics, new domain is the quantum physics inspired neural network. Why quantum physics? Because Raman spectroscopy itself is a molecular physics and based on the quantum network. So we have a non-linearity, we have a complex decision boundaries, and then we have the efficiency. And as I mentioned that the standard CPUs and CPUs, it runs on this one, but it can expedite if you have a QPU, that is quantum processing unit. So then in the context of the QPin and quantum neural network, the main difficulty is the Baden plateau. The Baden plateau is a theoretical obstacle where you require that the training of the network becomes really impossible. So many of the global solution will come in presence of the local. So you will not be knowing that which one to access. And there only AI fails. So we require that the quantum neural network to understand that the entanglement case. And that's why I mentioned here that how that the first function becomes a flat. Yes, now, if you look at the prescriptive analysis that I mentioned, I can skip that. And now coming back to the actual Raman spectroscopy. So at present, the quantum neural network with the quantum physics, we are applying to the problem of the Raman spectroscopy. Raman spectroscopy, in a short, that you have a spectrum, you have a wavelength shifter. From that the wavelength shifter, we can find it out what is the content of that the molecule is. Okay. So this is the actually experimental spectrum for the various type of domains. This is the Raman spectrum of deep glucose, this is a powder form, and this is the Raman spectrum of the liquid water. So this whole thing, the spectrum processing with the help of the quantum computing only we have achieved, and we have given the recommendation to the lot of pharmaceuticals. If you use that, you will have the lot of impurity. You can improve your drug. So these are the various kind of, you see one of the domain of the research is quantum signal enhancement. Deep pressure extraction, that's the Raman shift as I was mentioning. This only we require to complete. Okay. So one of the things we taking here, that protein folding and biopharmaceutical theory. Okay. So we have a amide 1, amide 3 mixed markers. Lot of physical constraints should be there. Non-invasive glucose monitoring theory will be analyzed here by using that. And what we are trying to do, the steam forest, this is the problem. So steam forest means glucose is a weak Raman scatter, so its signal is buried under the forest, louder signal. So definitely from the steam, collagen, lipids and water, we require to extract. So QPin solution is giving lot of things, and you see that there are two wavelengths, 1125 and 1445. That will be used as the band pass filter for band pass Raman spectroscopy, and thermal rationing will be there, and physically interpretable matrix will be solved. So then, if you look at your data needs accuracy, logic, speed, these are the features. Based on this, your standard machine will having this kind of 10,000 samples. But QPin, if I apply, I need that there is 70 to 90% of your samples. That means less data, it will work. I want clean lab samples, but I want the dirty real world. That means I don't need any clean and green room if I apply the QPin, or if I develop the laboratory with respect to this particular thing. It looks like a glucose, but physics says that this must be glucose. Okay, so there is no ambiguity. Speed is very slow here, but here is the instant, immediately you will get. So therefore the loss function is calculated by using this algorithm. There are the various weights in the neural network. These weights are required to be executed or required to be evaluated. So you have a data consistency, you have a vibrational constraint, And when you go for the evaluation of constraint, as per the molecular physics theory, we require the Clamart-Sponning relation that we adopt in that. And then you have a loss of thermal, which is the Boltzmann balance. Then you see that the raw Raman spectrum, and with the help of that quantum neural network, we have that the RMSE value is very nice. So predicted versus actual, you can see that how beautifully it can map to that thing. And for this, you need that the only quantum computing programming. We have a Qiskit, we have a Pennyland, and that you can, or you can use the Google Colab. Okay. So then you can see that the various bands we can apply for the different QP at the epoch of the iteration. That test RMS is 147.91 came, and there are various zones I have explained here. Okay, and various zones which will remember with the help of the quantum computing. And classically, if you go, you may not be having that zone A, zone B, zone C, zone D distinctly. But domain knowledge is a molecular spectroscopy. Okay, so why quantum is required for Raman? Because it is inherently a quantum phenomenon, as I mentioned. So you can activate the functions in the first layer, that the neural network acts as a Fourier-like filter. So you can rename the Fourier filter, and you can isolate the harmonic, and you can have the phase sensitivity. So that is why all these things we can do by quantum inspired for the Raman. Then we require the quantum kernel approach. This is basically support vector machine, and when you do that, you can have a bonding, HOH bonding, with the help of the physics information network. And in that case, we try to solve the Schrodinger equation or the harmonic oscillator. And it is very yet to know that if you are really working with the actual system, the Schrodinger equation is ultimately the equation for quantum processing. For example, those who are the thermal engineer, they solve the Barger's equation. The Barger equation, when we come back to the Schrodinger equation, I can solve the temperature distribution of the medium. And how to convert that AI will not do. That you have to understand the domain, and you have to apply that a Barger equation can be converted into a Schrodinger equation. Similarly, there are any viscoelastic parameters are there which can be converted to the quantum computing solution. So that is why you go for the physics informed approach. The Raman shift can be an energy minimization. We can construct the Hamiltonian, and Hamiltonian ground state energy we can construct as a minimization process. And these are the deconvolution things we are showing when we run for the physics inspired neural network or quantum physics inspired neural network. With the help of that, you can see that very nicely we can prepare the deconvolution. So therefore, we can claim that more real-world applications of the QPIN are coming in the pipeline. That the financial fraud detection, genomics and drug discovery. Actually, at present in Heritage, we are working on that. We may get very recently an ICMR project on the 45 lakh because of this approach. And then we have a supply chain optimization. This, of course, is a very important problem. You can simply solve the students, you can solve this traveling salesman problem with the help of the quantum neural network and see the difference. So current challenge is the current plateau that we have to think about that. Hardware noise, because qubits are fragile, decoherence takes place very often, and the cost running a complex QNN is a really costly. So we require that there is ion tube, ion trap, or any kind of other machine. So my conclusion is that current trend of data analytics are discussed. Quantum neural network is a new domain of the data analytics. With the help of the quantum physics or simply physics, you can take that where overfitting and underfitting issues can be removed very easily without introducing any kind of Lagrangian method of undetermined multiplier or penalty function. Then future data analytics will be definitely based on quantum machine learning. So my request to the students that you study the neural network, but always redirect your brain towards the new domain of data analytics, which will be coming in future within very short time, maybe the 2 years today on. Thank you very much for giving me. Time has changed, so therefore we are required to know that how we can implement the AI. AI is really having a good impact in teaching and learning also. I am not favored to the previous future. AI has got a good impact where the complex problems like quantum computing cannot be solved. You can take the help of AI and see that the direction you can do. Okay. So today parents are asking that where my children will send to the US or UK. Who will answer? You ask that you make a module by giving the history, it will answer. And then you analyze that. If you have a cancer, you are going to the doctor, your family physician first. The family physician tells that yes, you are having a cancer. Then do you agree with him? He will always consult with another people. So nothing but. Today we are doing the e-life, online shopping. Online shopping is what? It is an AI agent. You are giving that your solution from the net, but the person who is using, he is going to here and there and collecting and giving it to your door. I have experienced, I have asked one person, what are you searching? Oh, some of my customers have put that the online order, but I am not getting. Then I have to, you are not getting, you ask that your AI and see that where you will get. He immediately listen me, put that thing and give that the direction that, oh, you go to that Kasba area, there you will get. He got that. So AI has got a good impact.
Excellent.
Thank you
Excellent.
very much.